Let's discuss standardized work. So standardized work concept in lean manufacturing. Uh, there is no one best way to do the work. Um, Workers should design the work. The purpose of standardized work is to provide a basis for improvement, and standardized work is constantly changing. You're always trying to find a better way to improve it. And you always use the workers to do that. So lean is different than methods engineering. Under methods engineering, the engineers design the work, and then they just told everyone this is how you're going to do it. Under lean, the thinking is to engage the workers so that you can get feedback from the workers. You can, as we mentioned earlier, always get continuous improvement, and you're working on a daily basis and knowing their work is better than anyone else. So as for the system overview, the main goal is to provide a required level of output that can meet the company's expectations and the customer's expectations. So under lean, you're always thinking customer, customer, customer. So as far as the input, you got the man or woman, machine, material, method. All that goes into the plant or the facility that you're working in. And the output is productivity, quality, cost, delivery time, and safety and environment and morale. So maximum utilization of machine, what's the problem with that? Well, you're running the machine constantly and you'll produce overproduction, which is muda. And you also need extra people if you're going to just run the machines um, to their max. However, under the maximum utilization of people or the lean concept, you will increase your utilization of available facilities, and in turn, you'll do it with less costs and waste. And the lean system standardized work will focus on human movement and human involvement. So what are the prerequisites for standardized work? Well, the most important prerequisite is stability. Your facility must be stable. So it's hard to introduce standardized work if you don't have a stabilized facility. So you really have to focus on that first. The next prerequisite was for machine stability requires 5S and TPM. I've always said that a world-class facility will start with 5S. That will be the foundation of any world-class facility. If you don't have walk into a facility and the place is not clean or well organized, you can tell a lot about that facility just from just walking in. Quality is strengthened with Jidoka, so you're eliminating defect correction, and you're running hopefully good parts at all time if you standardize it, and use just in time to solve part shortage problems. So the importance or benefits of standardized work. Well, again, you have process stability. You have a clear stop and start point for each process. You'll have organizational learning. You'll have audit and problem solving, employee involvement and poka-yoke, error corrections by continuous feedback. You'll have a Kaizen, I always call it a spirit of Kaizen. You've got people who are an organization that always wants to continuously improve, and you'll have training. So what's takt time versus cycle time? Well, takt time is the actual time it takes to do the process. Cycle time is the estimated time for each cycle. So a lot of people use takt time as cycle time, but they're two different things. So the goal of lean manufacturing is to synchronize takt time and cycle time. So takt time allows you to monitor the production system, and you can determine whether it's going fast, if it's going fast or if it's going slow. So work sequence defines the order in which the work is done in a given process. The requirement is to define the best way to do the job action at the proper sequence. So picture and drawing of work sequence should be provided, indicating that there's proper posture, how the hands and feet should move, how one should hold the tools, the critical quality or safety items that should be involved. Uh, do we need in-process stock? So the fact is that the work cannot progress without a certain number of pieces on hand. So yeah, you're going to need a little bit of work in process. However, the in-process stock should be increased in the following circumstances. Quality check requirements for additional work pieces. So if within the process you need to do a quality check on 2 pieces per hour, then you need to have that built into your in-process stock. Machinery cycles automatically, or machine operation in reverse order is in the reverse order of the operator. So here's kind of what a standardized work combination table looks like. So it provides the work elements and their sequence, and within each work element, there's a time per work element, um, how many operators and machine times needed to perform the elements or the work, interaction between the operators and machines, and the interaction between operators. So if you look at that combination table, and there's a time for each operation, so if you add up uh, that entire the time for each element, then that gives you the total time to complete the work. So the standardized work analysis chart it will comprise of the work layout, the process steps and times, critical quality and safety items, and standardized work in process stock. Job element sheets are a one-pager that defines actions making up the job element, the rationale, pictures and photos highlighting key points, and a revision record. Time measurement, the required steps are for time measurement is become familiar with the process area first, draw the process area layout, show the work elements, write the work elements, measure the total cycle time at least 10 times, measure time for each work element at least 10 times, take the average of that after you do that 10 times, identify and measure irregular work, and write the standardized work analysis chart and standardized work combination table. An operator balance chart shows the total time considering fluctuation, which is cause of instability or changeover, product related, periodic work or process related, such as cleaning a weld tip, an element time, value added work, MUDA, incidental work, change or no change. So that's what the operator balance chart will show. So standardized work in Kaizen. So Kaizen opportunities are obvious in cases like reoccurring defects, machining breakdowns, excessive WIP, hard to do work or MURI, or unevenness or MURA. There are guidelines for obtaining Kaizen by economy of motion, or designing the layout and equipment, following guidelines for tools and jigs. So there are different types of layout. Islands or isolated processes. Forklifts will move piles of inventory between islands. There are connected islands where conveyors connect islands to move the inventory. There are connected islands with full work control. A visual device controls the amount of inventory between processes, and there are cells. Machines are placed side by side, and there are minimal inventory between machines. So in summary, standardized work is used as a base for improvement. Workers are involved. That's very important to have worker involvement. Use people or machines. You must have a stable process. That is key. Kaizen or continuous improvement, you need to have that spirit of Kaizen. You need to understand tech time versus cycle time, understand what work sequence is, uh, know sheets, tables, and charts for specific purposes, and understand work area layout.